Hi, Integrated 1 students. This is Mr. Rain. Sorry I'm not here in class again. I'm at a district meeting today, but definitely wanted you to get a lesson today, so don't want you to miss out on it. So today you'll be watching the video. Again, if you don't get something, you could go back to video. Please come back with questions tomorrow. So we all need to have our notebooks out, and let's write down the title and the objective for us today. So, and then let's have the teacher pause the video so students could do that. Alright students, so you should have written these things down. So today we're going to recognize a linear function in context by analyzing constant rates of change. When we see the words context, when you say in context, it means like, what does the story say? Okay, so let's write that down in our notes. What does the story say? Right? So sometimes, we have math, and math is really, gives us a bunch of numbers, and sometimes we need to know what the story says to understand it. So, okay. Let's go to the next slide here. Here's some vocabulary. So we don't need to write this down, but we'll go through it, okay? Linear function, let's all say the word or the term linear function. Alright, so a linear function is a graph, and is a straight vertical line. It's supposed to say a graph that is, let's put that here, is a straight vertical non-vertical line. It can be represented by an equation written in this form. So this is one of the forms we're going to start looking at now. AX plus BY equals C. Let's have you students write that down for about 10 seconds. Alright, so this is the standard form of a line, so you should start memorizing this. We've talked about discrete and continuous functions. So a discrete function is a graph has unconnected points. So remember from before, like let's say I had a graph and then it had points like this. Even though they're in the straight line, they're not connected, so that's discrete, right? Continuous is a graph that is unbroken or a curve with no gaps. So like, let's say I connected a line through all of these, then it would be continuous. This red line is continuous. These points, though, by themselves are discrete. Okay, and then solutions of linear equations in two variables, any ordered pair that makes the linear equation true. So basically, let's say I had this line here, and let's say I had this point, a second point right here, and let's just say this was 1, 2, 3, 4. So our answer would be 4 up, 1, 2, 3, 4, 5. Let's just say that's 5. I know that's not perfect. That would be the solution, 4, 5. Okay? You don't need to write this down. These are just some ideas. So let's continue on here. How to determine if we have a linear function, okay? So linear functions, we need to know, sometimes things are not linear. Remember yesterday we talked about the tiles, and when we plotted the points on the graph, those tiles were not linear. They're actually exponential. So the domain needs to have a constant rate of change between consecutive terms. We're going to talk about how to determine that. The range needs to have a constant change between consecutive terms. The x value is a single power, and the function can be written as this. Okay, so here are some rules. Let's have the teacher pause the video for about a minute. Let's have students write this whole slide down, okay? Let's pause the video, please. Alright, students should have written this down. These are some basic rules, okay? I know there's going to be steps in the next slide, but you still need to know how to do this, okay? So, here we go. Here's number 1. Determine if the equation is linear. If so, graph the function, okay? So, steps right here in the middle. We'll write this down in a moment. I'll do a few of these together, okay? Numbers 1 and 2, and then number 3 we'll do together. Okay, so number 1, 2x plus y equals 4. So the first thing I want to do, let's look at our steps. Determine if the equation is linear. So remember, we could determine if the equation is linear. Let's look back at our notes right here. The domain and the range needs to have a constant change. X value is a single power, so let's look here. Is my x value a single power? Sure is. It's x to the first, right? And we ask ourselves, is the function written in standard form ax plus by equals c? Yes, it is. It looks like it. 2x plus y is equal to 4. So at this point I would say yes, this is a linear function. So now I want to do step 2. If it is, we're going to create a 3-part chart. We do that by just creating an x and y table with inputs and outputs. Okay. So we're using our ingredients here that it's given us, -1, 0, 1, and 2. We've done this before. And we're plugging these in for x and figuring out what y is, right? So it's kind of easier to figure this out if we solve for y first. So I'm going to rewrite this 2x plus y equals 4, and I'm going to subtract 2x on both sides so that we get y by itself. Y equals 4 minus 2x. That'll make it a lot easier, okay? Here we go. I'm going to plug in -1. What happens if I put -1 here? Well, -2 times -1 is 2, and that's positive 2, right? And 2 plus 4 is 6, right? So put a 6 here. Let's put 0 in. 0 times -2 is 0. 0 plus 4 is 4, right? So I'm going to put a 4 here. Let's put 1 in. -2 times 1 is -2, so 4 minus 2 is 2. You see what pattern is happening here? The next number, let's see what happens. Let's put 2 in. -2 times 2 is -4. 4 minus 4 is 0. Okay? So we've just made these. These are our ordered pairs now, so I'm going to make a graph. Very simple graph here, an x and a y axis. And I'm going to plot my points, -1, 6. So we go -1, up 1, 2, 3, 4, 5, 6. That's way up here, but that's okay. Next point, I'm putting arrows at the end to show that this goes on forever. Next point we said is 0, 4. So we're going to start at 0, up 1, 2, 3, 4. There should be a point there. This is an arrow right here. It's probably too big. Okay, next one, 1, 2. 1 up 2. And then 2, 0 right here. Okay, so I'm noticing these are all in a straight line, so I'm going to graph them. I'm going to create a line here. And draw arrows at the end, and I'm done. Okay, so we just graphed this, right? And it worked out to be a line. So step 4 now, we're not done yet. If you look at step 4, it says label discrete or continuous if necessary. So we know that this is continuous, right? Because the points are all connected. We notice that it's going down by 2. How much is it changing every time? Well, it's changing by -2, right? So it's definitely continuous. That's our difference. And then our domain here, let's just list the domain that's present, right? So this line is actually not discrete. It includes every point in the middle here. So just to make it simple, our domain is going to go from -1. We're going to look at the smallest point here, and it's going to go all the way to 2. Put an x in the middle, less than or equal to, less than or equal to. And that's it for that. The range, we ask ourselves how far down to how high up does the graph go? Well, it starts at the bottom is 0 here, right? You'll see that it says 0. So I'm going to put 0 down. The highest point it goes to is 6 on the y-axis. And we're going to put a y less than or equal to, less than or equal to. Okay? And that's how you do number 1. A lot of work, I know. So let's have you kids talk about it. So it's Tuesday. Let's have 3s talk today. So let's have 3s talk to the rest of their groups about how to do number 1. Okay, so let's have the teacher pause the video here, and kids will talk. After they're done talking, let's have kids write down number 1 and the steps, please. Ready, set, pause. Okay, great. So students should have written down number 1 and the steps. Number 2, let's see if this is a function. Well, it kind of looks like it's in the right form, right? Standard form, ax plus by equals c, right? But there's a problem. There's a squared here. Are we allowed to have x squared here? No, it should be x to the first, so can't really include that. So is this a function, or is this a linear function? No, not a linear function. Okay, so we would leave that alone. Number 3, is this in the right form? Well, there's a 4 underneath the y. We could get rid of that pretty quickly. Let's multiply this whole left side by 4 and this whole right side by 4, because the 4's will cancel out. So 4 and 4 for the y term, we'll just leave y, plus 4 times 2 is 8 over x, which is equal to 4 times 3, which is 12 over 2. Now, is this in standard form? No, it's not, because we're not multiplying a or 8 times x, we're dividing it. You see how there's a division sign here? I'll use a different color. And this is supposed to be multiply. It's supposed to be a times x plus b times y is equal to c. So this is also not a function, okay? Not a function. Alright, so we've just done 1, 2, and 3. Let's keep going here. We're going to do a different kind of problem. Let's shift gears a little bit. Let's talk about discrete or continuous. Let's spend a moment here with our groups. Everyone's discussing. Remember, discrete is various points on a graph that are not connected, and continuous is when things keep going on forever, okay? So let's have the teacher pause the video here and have students talk about this for about a minute. Okay, so the number of basketballs manufactured per day, is that discrete or continuous? Well, I would say this is discrete, because at the end of the day they give us a tally, right? On one day they might make 100 balls, the next day 100, the next day maybe 200 basketballs, right? So we don't really count in the middle of the day. So this is going to definitely be discrete. Number 2, the number of bullseye scored for each hour of practice. This is also going to be discrete. Discrete. Okay? Because at each hour we're going to count how many bullseyes are scored, right? So it's going to be once an hour we're going to count. We're not going to constantly count or continuously count. Okay, then the next one. Y equals 35x to the first, where x is the distance and y is the height. This one is going to be continuous because I could graph it and it would show a line. Continue. That's okay. Next one, y equals 4 to the fourth x, where x is the time and y is a gallon of water. Okay. This one's actually going to be continuous also. We could graph this with an x and a y, and we'll actually get a line or a graph on here. Okay. Next one, the amount of boxes shipped per shift. This one, it's going to be discrete, right? Because we're gonna count it at every shift, right? Shift 1, 2, 3, 4. Maybe the first shift it's this many. Maybe the next shift is a lot. Third shift is lower. Fourth shift is like that. Now I know you're thinking, like, can we connect the dots? Yeah, but we are not connecting the dots because we're only counting once per shift. Okay, last one. X is equal to y over 4, where x is the number of hours and y is the miles walked. This one is actually going to be continuous, okay? Because we have an x and a y. When x changes, y changes, and we can make x and y. We could take little increments of it, right? Even though we're talking about the number, we could take half hours, right? Alright, so we'll practice those as we go. continuing on here. Alright, let's do one more here. Hans opens a new video game store and pays the gaming company $5 for each video game he buys from them. The amount Hans pays is given by this function, f of x equals 5x, where x is the number of video games purchased. Okay, so we're going to graph this. Let's pause the video here. Let's see if the students could graph this. And as you do it, kids, remember, try to make an XY table. I'm going to just give you a hint. This is going to be a linear function, so we could assume that. And think about it. Can we have negative numbers here, like -2 and -1, right? Let's look at our x-axis. Can we have negative video games? No, we can't. So we don't want to include those. Let's start with 0. And let's just do all the numbers that are in our domain down here. We have 0, 1, 2, 3, 4, and 5. Okay, let's pause the video here. Okay, students should have worked this out. We have a function f of x equals 5x. We're plugging this in, so I'll use a different color. We got 0 times 5 is 0. 1 times 5 is 5. 2 times 5 is 10. 3 times 5 is 15. What's the rate that it's going up each time? 5, right? So the next one I'm predicting is going to be 20, right? 4 times 5 is 20, and 5 times 5 is 20. When you plot these as ordered pairs, you're going to notice that you're going to get a line, right? And we're going to graph our line, of course, and as the student has more video games, the cost to the student is higher. Okay? Anyways, that's the last example we're going to do together. So what I'd like students to do, let's pull out our workbooks. You should all have it page 31. You're going to do numbers 1 through 12. And this will be due tomorrow. And you know your AM 2.0s are reset, so make sure you're starting those up again. I'll talk to you about those tomorrow when I get back, okay? That concludes the lesson. Thank you, kids. Bye-bye.